Greetings, the Astro 30 here yet again, and welcome back to AEL. If you're new to this channel, please consider going down below and subscribing if you haven't done so already. Thank you. On the desk in front of me is another bunch of PCBs that I've ordered, and by the title you've probably guessed as to what it is, but no one's seen it yet. Neither have I, actually. So I'm going to open the box to reveal my PCB packaging, and there's two here. There's a smaller board which is going to be used to mount the negative temperature coefficient thermistor to a heatsink easily. So, but that's not really relevant to this at the moment. What is relevant is this particular PCB, when I can find my scissors and cut the bag open like so. Yeah, it's like Christmas. I love receiving new PCBs. Take the boards out the packaging and unwrap this to reveal. Oh yeah, that is so sexy. Although the silk screen is a bit screwed on that one. There is a hole here and some copper is showing through, which is annoying. It's only on one board. It looks like it got scraped at some point. That is pretty poor manufacture. Okay. Looking at another PCB, this one looks in better condition. Anyway, it'll still, the PCB that's got the little bit of copper showing will still work, and the capacitor will most likely cover it anyway. Although I've used the wrong footprint here, I've used way too large of a capacitor footprint, but okay, that's alright. So I'm going to need to go out and get a 10K trim pot to put in here because I don't have one. I've got a 20K, but that's too high. Yeah, so this is my PWM cooling fan servo PCB, which I did a video on breadboard, which I'll put up the top here so you can look at it if you haven't seen it yet, and learn about the operation of that. However, this is what my PCB looks like, and it should serve the purpose perfectly. Now, I've done another footprint with one of these PCB mounted heat sinks, but I've made the holes here 2.3mm. The last set of PCBs I used this on, I made it 2.2. It's still a little bit tight. So what I need to do is find a heatsink wherever I've put that and see if it will fit in the board. My one and only remaining heatsink, which still has its pins on it. So push that in. Yeah, it fits perfectly. Does overhang the board a little. That's neither here nor there really. That's fine. And for the amount of current that the fan draws anyway, this heatsink is probably overkill, and you could get away with, say, one of these type of heatsinks just fine, which is actually the original transistor I tested the circuit with in the first place. There's also a hair hanging off that. Nasty. So yeah, that's that. So it depends on your cooling fan too. When I tested the fan I was using, it was around about 150 mA at full speed, which is naff all. So that's that. Now when I assemble this, I'm going to just put in fly leads for the connection points rather than connectors because, well, it saves making up cables, and I'm not sure when I'm actually going to use this PCB for anything. So that's how I'm going to connect power and test it in the fan and stuff. So those are the PCBs. The other four, the silk screen's fine on. It's just this first one, which is not So I might actually, because I've paid for this, I might actually take a picture of this and post it onto PCB Way and say that 1 out of the 5 PCBs has a copper showing on the top plane, which it should not. So it's been scraped, so it's damaged. And it was not I who damaged it. So I might be able to get a bit of a discount maybe. So yeah, I don't know. I'll have to look on the website and see what we can do there. So I'll put that one PCB to the side and I'll keep another one to the side ready for assembly. And I'll put the rest back in the packaging. And we'll have a quick look at my have a quick look at these PCBs so you can see what's going on here. So I'll just open this packaging. And I only got 5 of these as well because it was unnecessary getting more than I needed. Because, well, I only have 5 of the other PCBs and I don't need more than 5 of these sub-PCBs. Which is probably the smallest PCB I've ever had manufactured. Look at how tiny they are compared to my fingers. And that's all its purpose is to just connect the thermistor to a standoff against the heatsink. Obviously this is the copper side, so you would put the standoff on this side. And then the NTC, I keep calling it a PTC there. And I have made it for a connector to be put here, but well, you wouldn't. You would just put 2 wires there instead. Yeah, so that's the little PCB. It's also not routed correctly. It's got a bit of a notch on it. In fact, there is another one here which also has a little bit of a notch on it. I mean, I'm not so worried about that too much. That one has a notch there. So the notches are in different places. It must be how they routed it to cut it out. This one's got a notch as well, just there. And finally, this PCB here also has a notch. It must be because these PCBs are so tiny that getting it to route straight is kind of difficult for them. Because it's so small to work with, they've got really nothing to grip to. I'm not worried about manufacturing defects such as that. I can always take a file to it if it really does my OCD. However, manufacturing defects such as that, I am not happy about. And I am going to worry about. Because that's a potential short circuit right there. Not that it would. That's the ground side anyway, or the negative of the circuit, so it's not going to really be that much of an issue. But it just looks ugly. That's the main concern I've got. So yeah, I'll probably get on to PCB Way about that and see what they can do about that. The rest are fine. So alright. So what I'm going to do now is I'm going to get to assembling this PCB after I've gone and got the 1000 microfarad, a couple of 100s, and well, a 1 microfarad because I don't have one. Not a brand new one, I've got a used one, but I'd rather use a new one. And yeah, we'll get to assembling it. Excellent. Okay, well it's the next day now and I've got the capacitors that I need and I'm ready to assemble this PCB. So what I'm going to do is I'm going to mount it into my little tool here. And I'm going to, well, film this in time lapse, I guess, of me assembling it, just for something different to do, because I don't normally do time lapse videos. So I will assemble all the components apart from the transistor and heatsink. That'll be done after all the other components are installed. So I'm going to start with the resistors, low profile components like that, and the diode. Then I'll put probably the IC sockets in that I'm going to use. Then the 4 PCB pins for the test points. And the variable resistor. I might do the variable resistor first, then the PCB pins, then the capacitors. As I said, I'm not going to put connectors on at this stage. So this should only take me about probably 15 minutes to assemble. So Alright, cue the music. And there we have it later, about 13 minutes later, according to the camera's time display. That's how long it took to put this together. So, excuse me, I was stalling a little bit on these resistors here because I was reading the values on the colour bands, and the 10k ones look exactly the same as the 1k ones. So I was just trying to discern whether they were the correct value. These two here should be 1k, so I should be able to measure that in circuit anyway, just to verify that I've got the right resistor in the right hole. Nothing worse than being completely wrong. So that should be 1k. Oops. Which it is. That should be 1k also. If it would give me a reading, that would be nice. Yes, that's 1k. That one should be a 10k. And it is. That one also should be a 1k. Which it is. And that one should be a 10k. Which it is. And this one, I can see it's 100k, it should be 100k, and if it would measure, come on, get on there. Yeah, 100, right, okay, so all the resistors are correct, so there's nothing worse than putting the wrong resistor in there and then wondering why the circuit doesn't work, or didn't work as it did in the first place, so that's good. And also, I did manage to get onto PCB Way about this damaged PCB silkscreen here, and they offered me $1 US added to my account. Now, I accepted that because I said to them I don't want to get a full refund because I got 4 perfectly good PCBs here. So they offered $1. I accepted because, well, this was a batch of $5 PCBs, so there was 5 of them, so 1 is $1. So I got an extra $1 back, which was cool. This is probably salvageable. The only issue is there's bare copper exposed here, so you'd want to seal it, like either put a drop of solder on it or reapply some solder mask. But yeah. So what I need to do now is mount the transistor, which I'll do in just a second. But what I want to do is I can use these 2 test points for the fan because they go to the same points as this connector here. This top one is the negative, this bottom one is the positive. This test point here is just measuring the frequency output of the 555 timer. So I need to get in a couple of leads here for the power supply input, just so I can test it. So that's what I'll do first, and then I'll move on to the transistor. Alright, I've got my transistor, screw and heatsink ready. I've just got enough height here with the heatsink and this capacitor in the way to get the screwdriver in there, so that's alright. So I'm going to, well, probably to the back of the transistor will be better. Just apply a small amount of this compound. I don't need a lot. I ended up buying a syringe because the little tube that I've got is very runny, and this stuff seems to be a little bit more not as runny. So that's that done. Now I can put my screw in and start it off in the heatsink, but I'm not going to tighten it yet until it's in the PCB. So I've got some room to maneuver the transistor around so everything fits in there nicely. And the amount of compound I put on there was probably a little bit too much, but that's okay. So now I need to get this to go in the holes, if I so can, without making a humongous mess with the compound. There we go. And now I can solder him and then tighten the screw. And no matter how good I am with that compound stuff, I still manage to get it on my fingers. So I might start with the heatsink itself, just make sure everything is flat, which it is. And just solder the legs of the heatsink in so that's permanently to the board. I could have probably put it back in my little mounting jig, but I decided against it. It's unnecessary. There we go, that should be enough. Don't want to overdo it. In fact, yeah, I might actually mount this in the thing. That might work a bit better. I've put some fly leads in for the positive and negative connections for the power supply, so the NTC I'm just going to stick in its holes and just hang it off the board to do the testing with, because that goes onto a sub board as I previously showed in the intro. Right, that's the transistor soldered in, so I will trim off the excess lead length here, which is not necessary. Excuse me. And there we go, that's that done. So now I can take it back out of the jig, drop it on the desk, and now do up that screw tight. So probably got a little bit too much heatsink compound on there, but that's alright. Okay, that's tight. And there we have it there. Assembly is complete apart from two key components, and that's the ICs. So I need to put the 534 in, 534, sorry, the op amp. So that goes in this one. Otherwise we won't have a comparator. That's that. And this case an LM555 timer. I think that's what it says. I can't even read it, let alone, that is kind of annoying. Yeah, 555CN, LM555CN, put that one in, drop it on the desk, pop that in its socket, maybe straight would be a good idea. Okay, and I'll just compare it to the other circuit board, make sure I got it oriented correctly, which I appear to have done so. Okay, now we're ready for testing. Okay, so I've got it hooked up. Now, I didn't really need to put this fly lead in here for the negative. There's a ground over here anyway, but it's in there. Now I need to find out what I did with my small screwdriver. There it is. I just want to make sure Now I'll use this Phillips head one that I've got knocking about. I just want to make sure that that's set to the center to start with. I ended up tacking the NTC in so it's not just floating around. Right, that's in the center. Power supply's hooked up but not turned on. It's turned on now, we're about 12 volts. Turn the load on. Nothing happens. See if I can make this do something with my finger. Probably not, so I will just this. There we go. Well, that's a good sign to see that it's working. Okay, so center's about right, but my finger's not hot enough, so time for the old trusty soldering iron. Here it goes. And that's kind of running at full speed. So that pop might be a bit touchy. So right in the center it takes quite a bit of heat for this to make it take off. But it is functioning. And my finger makes it stop because my finger's colder than the soldering iron. So the circuit works. Isn't that wonderful? It's always good when you build something or design something like this and it works first time. I mean, I've already done the preliminary testing on the breadboard before, but to finally see it as a final product is... there was one change I did make. There's an extra 100 microfarad capacitor here, which goes between the base and ground of this output transistor. That just helps filter out the PWM signal on the output a little better, so you can't hear this thing squealing. When it's going slow, you can hear it squealing, but a little bit, but it's not as obnoxious as it was without it. And it still needs a 1000 microfarad here on the output to filter it even further. So the circuit works. I'm happy. Yeah, there's not much more I can really do with this. I mean, we could stick it on the oscilloscope and look at what the output signal is doing, but I don't think that's really necessary. But I guess we'll just do it just for the sake of doing it. Okay, it's hooked up to the oscilloscope. I've adjusted the yellow trace down because it's a DC signal. Power supply is off at the moment, and it's very hard to film this TFT screen and make it go in focus. Anyway, I'll turn the power on, and as we can see, we've got a signal there. Currently we're at 1.28 kilohertz. So I'll bring in the soldering iron and heat the NTC, and we should see that duty cycle change sometime today. There it goes. And if I remove the heat, we should see the duty cycle change again. There it goes. It was up to about 211 Hertz. And it's dropping down, down, down. And then settling back out with the fan stopped at 1.27 kilohertz. Neat. So there we go. That's that circuit working, tested, and we've seen what the waveform looks like on the output. So I don't know if I mentioned it in the beginning, but I'll mention it now. I will make the PCB available on PCBWay as a orderable project, and it'll be complete with the schematic on there as well if you just want to look at the schematic. There'll be a link in the description below. Anyway, I'm going to leave this video here because there's not much more I can do with it. because, well, I haven't decided what I'm mounting it in yet, or for what purpose I'm using it for. But that'll become apparent over the next few months or so. Anyway, if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And this is the Astro 3 saying, see ya, have a great day and keep cool.